Hello students, and welcome back to another lovely day of physical science. In today's lesson, we are just going to actually get some practice with that density equation that we learned about. So, for this density equation, couple things that we need to talk about first. Density, we need to talk about units. So density most commonly in this class is going to be grams per centimeter cubed or grams per milliliter. Realistically, density is any unit of mass divided by any unit of volume. So you could have kilograms per liter. You could have deciliters per yard cubed. It doesn't matter. It's literally any mass over any volume. But most commonly in here, it'll be grams per centimeter cubed or grams per milliliter. Mass, again, most commonly is going to be units of grams. You know, you could have kilograms as well as a pretty common one, but for the most part in here we use grams. And then volume is measured in centimeters cubed or in milliliters. Centimeters cubed is more used for measuring like solid objects like, like a plane dice or a box. Milliliters is more used for measuring a liquid like you've seen in graduated cylinders. So there are 4 steps to solving problems, and this is actually going to carry through into all of our physics portion of the class as well, so it's good to just start getting some practice on this. But first thing you want to do is define variables, and I'll talk about what that means coming up. Second thing is choose an equation. Well, today we're learning about density, so it's pretty easy to choose equations. Step number 3 is rearrange equation. Right now that's actually not bad either because we're going to rearrange all of them before we start solving for problems. And then step number 4 is just plug in the numbers. So while these 4 steps, are a little bit easier to do today, when we get to the physics portion of this class and you're choosing an equation, you're going to have a list of about 25 different equations to solve from or to choose from. So it's, choosing that equation gets to be a little bit trickier. Same thing, rearranging the equation. Well, we're rearranging all of them early today, but it gets trickier. So today is really practice using these 4 steps, and it does help you to solve the problems properly and to make sure that you're showing work. So let's focus on step number 3 right now, and let's just rearrange the density equation right now. So here we have the density equation, which is mass divided by volume. Well, there's this cool little shortcut that we can use that involves a triangle. So first thing you do is you draw a triangle, and then you split the triangle into 3 parts. And then all you do, and this actually works not only for the density equation, this works for any equation that is set up in this format. So you'll actually see, as we get through this class, you'll see like speed equals distance over time. Well, you can use this triangle method to solve for any equation set up similar to this. So what I'm going to do is density is on the left, so density is going to go on the left side of the triangle. Mass is up top, so mass is going to go on top in the triangle. Volume is on the bottom, so volume is going to go on the bottom right of the triangle. And now what we can do is use this triangle as a shortcut to rearrange the equation. That is to find an equation for density, find an equation for mass, and to find an equation for volume. So let's go through and find the equation for density first and see how do we use this shortcut that is the triangle. Well, in order to find this or to solve for density, what I would do is I would actually cover up density. So you can draw a smiley face over it or use your hand or whatever you want. So if you cover up density, you see that you're left with mass over volume. Well, that over means divided by. So the equation for density is mass divided by volume. Well, okay, you've already seen that over here. That's just fine. Let's try this for mass now. How do we use this shortcut to rearrange for mass? Well, what we would do is, again, we cover up mass, and now we see that density and volume are by each other. Well, that's actually density times volume. So our equation for mass is density times volume. And then the last one is just, what's our equation for volume? So we do those same steps. We're going to cover up volume, and now we see we are left with mass divided by density. So our equation for volume is mass over density. And hey, look at that. Now we have all three rearranged equations. So if I have a question that asks me to solve for density, cool. I just take the mass divided by the volume. If I have a question that asks for mass, well, I know I need to take the density times the volume. And if I have a question that asks for volume, I take mass over density. So, density practice problem. Let's remember our 4 steps, which is we need to define variables, choose an equation, and then rearrange the equation if necessary. In this case, we already rearranged all of the equations back here. So you'll be referencing back to this slide to find your necessary equation. And then we just plug in the numbers and make sure to include units. So first thing is let's define some variables and see what do I mean by define variables. All I mean is we read through the problem. What is the density? Okay, right there, that's a variable. And it's telling us we're solving for density. That's what it's asking. So I just say density equals question mark for now. And then we continue on. Of an object that has a mass of 680 grams and a volume of 50 centimeters cubed. Boom, right there. I have defined all 3 variables. I've said what each one of these is equal to. And this helps to make sure that when we get to more complex problems, you don't make mistakes. Step number 2, we need to choose an equation. Well, what equation do we have that has density, mass, and volume? Well, that's our density equals mass divided by volume equation. And it's rearranged already for the variable that we want. We want to solve for density, so we need density by itself. Then all we do, plug in the numbers. We said mass was equal to 680 grams. We said volume was equal to 50 centimeters cubed. We plug that into a calculator, and we get an answer of 13.6 grams over centimeters cubed. Again, just like you saw in dimensional analysis, grams and centimeters, they're not canceled out, so those units follow through. And so you end up with 13.6 grams per centimeters cubed. And then you think to yourself, would units of density be grams per centimeter cubed? Yep, they would. So we're good. All right, let's try another practice problem. What is the volume of 260 grams of lead? And we know that the density of lead is 11.3 grams per centimeter cubed. Again, follow your 4 steps, and I would like you to please pause the video and try this question out on your own. All right, now that you've had a chance to try this one out, the correct answer is 23 centimeters cubed. So let's go through and see how we got that answer. Let's define our variables. So it starts off asking what is the volume, so volume equals question mark, of 260 grams of lead. Since this is grams, I know that that is my mass. And then it tells me the density of lead is 11.3 grams per centimeters cubed. All right, so volume then, and you might have to go back a couple slides, but we found that the equation for volume was mass divided by density. So therefore, volume equals our mass of 260 grams divided by our density of 11.3 grams per centimeter cubed. And when you take 260 divided by 11.3, you end up with 23 centimeters cubed, because you'll notice grams on top would cancel out grams on bottom, just like you saw while doing dimensional analysis. So therefore, you are left with units of centimeters cubed, which is perfect because centimeters cubed are a unit of volume. And the reason that I want you to do these steps is in case you make a calculation error. And it happens all the time on exams or on homework. Students will go through and they'll type this into their calculator wrong and put down a wrong answer. Well, the issue is if you don't show this work and I don't see this work anywhere and you have a wrong answer here, I have to assume you did the question incorrectly. But if you go through and show all of this work and you have this 265 by 11.3 and maybe you have a number here of like 40, well, I can see, oh, they must have just put in their calculator wrong, not a huge deal, and you'll lose far fewer points because I can see what you did incorrectly. All right, last practice problem. What is the mass of 5 centimeters cubed, assuming the density of gold is 19.3 grams per centimeters cubed? So I'd like you to please pause the video and try and solve this problem on your own. All right, now that you've had a chance to try this, the correct answer is 96.5 grams. And let's see how we got that answer. First thing, we're going to define variables. It's asking us what is the mass, so therefore mass is equal to question mark. It says 5 centimeters cubed, which I know are units of volume. And then it says density is 19.3 grams per centimeters cubed. In this case, since I'm solving for mass, we're going to use our mass equals density times volume equation. Then if we go through and plug in our density of 19.3 grams per centimeter cubed and our volume of 5 centimeters cubed, we're going to get 19.3 times 5, and that gives us an answer of 96.5 grams. Again, here you have centimeters cubed on bottom, centimeters cubed on top, so realistically they would cancel out just like in dimensional analysis, and you're left with just units of grams. And there you go. You have learned how to solve for density equations.